Trigonometry. I'm going to tell you right now, I've been looking through the Regents exams and I've seen a bunch of problems about trigonometry. Even though they tried to take it out of the curriculum and make it all crazy and without its trigonometry, they somehow added a bunch back in. So I'm going to go through all the different kinds of problems that I've seen on old Algebra 2 Common Core problems. Again, I can't predict them all, but I'm trying to do my best. I call this lunch review because this is some review that I'm doing with my kids during lunch. So lunch review number 1. And it's trigonometry. And all of this stuff can be found at www.nkinfinity.com. All right? And if you go there, please do me a favor. Tweet this out, text it out, tell your friends in other schools. Let them know, hey, there's some review. Hey, you need some review for Algebra 2. We got it. It's right here. You can come on here. Now, I don't have a place for these yet because I just decided to start doing these. And I came down. So they're probably going to be down here. I might just call them lunch reviews. Lunch review 1, Trig. Lunch review 2. And I'll put the video link so you can download the document as well as the video. And they'll probably be here by the time you get here. All right, so let's get back to work. Let's just work. So the first few aren't too bad, and then it gets a little funky. All right, so all I said is relative to this function, what happened here? Now, I saw this on a multiple choice test. It was the first problem on a multiple choice test. I'm like, what? But it's not that bad, right? So notice we put in a negative. You need to write that's a reflection in the x-axis. Okay, then I added this part in. Well, remember, anytime you add inside the parentheses, that's a horizontal shift, left or right, but backwards. So instead of going plus, it's really minus, it's really left. So it's going left 2 pi over 3. And then this shift right here is up 3. Up 3. That's it. All right, this thing stems from a trig identity, and that you need to remember that sine squared x plus cosine squared x equals 1, so long as these are the same. So this has to equal this, or in other words, that thing has to equal whatever the heck that thing is. So that thing, there it is, has to equal 65 degrees. Is the sine curve odd or even? Well, you could try graphing it, and you could say, oh, look, there's the sine curve. It goes up in that direction and down in that direction, but it's cyclical, so it just keeps going up and down. So how do I know it's even? An even function is symmetric with the y-axis. An odd function is symmetric with or has rotational symmetry. So if I rotate this thing this way, right? If I take this thing and rotate it this way, don't I get this? Or do I have symmetry with respect to the origin? So this is an odd function because it has symmetry with respect to the origin. An even function, like the cosine curve, if I drew in a cosine curve, it has symmetry with respect to the y-axis. So this would be an even function. All right, just know those, okay? Those are part of the 2 flashcards that I have for you. Again, if you don't have the flashcards, come over here, go to the top here. There are directions on how to get these flashcards right here. All right, do your best. They're on Study Blue. It's a free app, easy stuff to get. I like it because you can put images on both sides. All right, so which one is the sine curve? Use your good test-taking strategies. It said sine. These 2 are cosine. They can't possibly be the answer because they start at a max and end at a max. Now, remember, period is defined as the time for one full curve. So, if I graph one full curve here, I stop here. How long is that? Oh, if I do one full curve here, how long is that? I don't know. All I do know is that the time should be 2 pi over 3. Well, if I look at this one, 2 pi over 3 is here. Did that thing finish one curve by the time it got to here? No way. It finished 3. So over here, it looks like this might be the right answer. Now let's see why. Remember the formula for period is equal to 2 pi over b, right? So b is the frequency, number of full curves in 2 pi. So how many full curves do I finish in 2 pi? 1, 2, 3. So finish b is really 3. Oh, 2 pi over 3. There's my period. So this was the right answer. Using the unit circle below, what is the value of theta if x, so, okay, since this is the unit circle, x is cosine and y is sine of theta. So what they're saying is cosine of theta is equal to the square root of 2 over 2. Well, you need to know that that means it's a reference angle of 45 degrees. Now, if you don't know that, you can always come over to your calculator, go into calculator mode, and do inverse cosine. Oh my gosh, I hate when my calculator does this. Inverse cosine of the square root of 2 divided by 2. Then you get 45 degrees. And notice you got to be in degree mode. So I know my reference angle has to be 45 degrees, but that's not what theta is. Theta is this. So it's all but 45 degrees. So in this case, theta is equal to 315 degrees. So I kind of fooled you a little bit. Over here, the y value, again, unit circle, but the y value is the negative radical 3 over 2. Well, it's negative because we're in the fourth quadrant. So the sine of theta is equal to, really to the square root of 3 over 2. Let's ignore the negative for now. The negative just tells us what's quadrant it's in. So if you don't know that this is 60 degrees, then you go back to your calculator and say, okay, sine inverse of the square root of 3 divided by 2. And you get 60 degrees. So I know the reference angle is 60 degrees, therefore this is 300. All right, let's try this one. A teenage girl's emotions follow the sine curve defined below. I'm sorry, girls. I'm just messing with you. I was messing with a couple of the girls in one of my classes. So where C of X is the crazy level. You know I'm a little bit crazy. You know I'm a little bit right here. What is the maximum and minimum crazy level of a teenage girl? Right? So max and min are always the midline plus the amplitude, and the midline minus the amplitude. By the way, the girls in my class didn't appreciate this, probably like you don't, but they also found it a little bit funny. All right, so midline. Remember, this is my midline, and this is my amplitude. So my midline is 25 plus the amplitude, 280. That'll be the max, which is 305, and that's my max. My midline, 25 minus 280. This is going to be my minimum, or negative 255 is my minimum. Simple as that, kids. Midline plus amplitude, midline minus amplitude. Remember, this thing on the end is your midline. This is your amplitude. A circle centered at the origin has a radius of 17 degrees. Okay, let's do this. Circle centered at the origin has a radius of 17 degrees, and the terminal side of theta intercepts the circle in quadrant 3 at point M. And point M, the y-coordinate is negative 15. Well, if you remember correctly, every time we do these kind of problems, we always work with triangles. So I know this is negative 15, and they told us that the radius was 17. Now, by Pythagorean Theorem, x squared plus negative 15 squared equals 17 squared. I can figure that out that x is equal to 8. But since I'm coming off in the negative direction, let's make it negative 8. All right. Now I want to label this thing opposite, adjacent, and hypotenuse. If this is theta, this is my opposite, this is my adjacent, and this is my hypotenuse. So sine is opposite over hypotenuse, negative 15 over 17. Cosine is adjacent over hypotenuse, -8 over 15. And tangent is opposite over adjacent, or -15 over -8, which is really just 15 over 8. All right, so I want to make sure you understand something. I'm not making fun of girls here. I just think it's hilarious that, and my daughter included, I have a 26-year-old daughter. She was an angel at school. I used to have people come up to me and say, hey, my gosh, your daughter's so sweet. And I love my daughter to death. She is awesome. But man, when she came home, she flipped a switch and she became, woo! But she's awesome. She's awesome. And you know, it's funny because I always will sit down with some of my girls and they'll be talking about their moms and their dads or whatever. And I'm like, how can you be so nice in school and be so mean and crazy to your parents? I don't know. They just butt heads. I think girls just butt heads with their parents a lot. Boys, they're like, sports, ball. Whatever. I'm just going to do whatever. Anyway, I have awesome kids this year. In fact, I was doing this review with one girl and she goes, oh, I don't know if it's funny. It's just true. And I was like, okay, whatever. I'm just messing with you. But kids, seriously, life is too short to get uptight about weird stuff. I'm just messing with you. I hope you had a lot of fun with that problem, but don't take it too seriously. I didn't mean anything by it. So I hope you enjoyed it for its craziness, and I hope it got you excited about trigonometry. Are you kidding me? Excited about trigonometry? I just don't want there to be that much on the test. Yes, you do. Anyway, let's talk about this problem. Now, if you press pause and try this problem on your own, and I'm going to tell you right now, you get this problem, you just went into like hyperactive beast mode, because this problem is not easy. Not easy at all. But it's fair game on the Regents exam, because it's going to separate the hundreds from the 90s. And, you know, and then all the people that aren't in the 90s, they're not getting this question right. This one's bad. I love this question, though. All right, so we read this question. We see that we have an arm that oscillates 100 centimeters. But if I look at all the answers, they all have 180 centimeters in. So this is a distraction. I don't need it because it has nothing to do with the problem. So I'm not going to worry about that. It's this piece right here that's just crazy, crazy, crazy difficult. So let's get started on it. 72 cycles in 24 hours. And I want to know about time in hours, just hours, 1 hour. So what I got to do is I say, okay, if I got 72 in 24 hours, if I divide by 24, that means it's 3 per hour. But I don't want 3 per hour. I want to know how long it takes for 1 period. Because remember, period is equal to 1 cycle. 1 cycle. How long does it take to finish 1 cycle? Well, if it finishes 3 per hour, then it finishes 1 in 1/3 of an hour. So the period is equal to 1/3 of an hour. That's the period. That was the hardest part about this whole problem, figuring that out. Now you got to say, okay, I don't know what I wrote parad over here for. So period, remember, period is equal to 2 pi over b. Correct? All right. Now, if period is equal to 2 pi over b, and I know my period is 1/3 of an hour, I can cross multiply to get b. Well, b is equal to 6 pi. And so I need to find the equation over here where b is equal to 6 pi, and that's it right there. Wow. Wow. I saw a problem like that on an old Regents. This one I made a little bit harder than the old Regents, but that's how you go about doing that problem. All right, so now we're just going to practice graphing. I think I got 1, 2, 3, 4, 5. I got 5 graphs we're going to practice. So you might want to try these on your own, see how you come up with them, and let's go. Let's get rocking and rolling. Okay, what do we got? Amplitude of 2, a equals 2. We got a period of pi over 3. Now, as soon as I see period, now what I'm going to do is figure out my x scale. My x scale, I always define as period divided by 4. Now, why is that? I'll show you in a second for those of you that haven't done this before. So this is going to be pi over 3 divided by 4. Now, when you divide by 4, you're really multiplying by 1/4, the reciprocal. So I get pi over 12. What? That's going to be my scale on the x-axis. So now I'm ready to graph, except for I got my y equals 3 is my midline. So I'm going to put my scale on here, 2, -2. And since I want a smaller pen, let's do this. Let me blow this up so you can actually see what I'm doing here. So I'm going to put my scale on here, pi over 12, 2 pi over 12, which is really pi over 6 if I wanted it to, 3 pi over 12. Now the next one I am going to simplify, and I'll show you why. This is 4 pi over 12. Now 4 pi over 12 is pi over 3. Now if I go back over here to the left, what's my period? Oh, my period is 4 pi over 3. So I should finish one full curve in pi over 3. Now the reason I do, you'll see why the reason I do this when I'm finished with this. Hold on. So now I'm going to draw in my midline. My midline is y equals 3. Since y equals 3, since it's a midline, it's not part of the graph. It has to be in dotted lines. So I'm just going to do a dashed lines because there's my midline. And that's y equals 3. Now, when you graph a sine function starts at 0, ends at 0, 0 in the middle. Starts at 0, ends at 0, 0 in the middle. Now, if it's a midline, if we've got a midline, now we've moved it up. So they're still going to start at 0, but start at 0 at the midline. End at 0 on the midline. Now, why did I come out here? Because didn't we say that we have a period of pi over 3? That means it's got to end at pi over 3. 0 in the middle. Now, I got to decide, am I going up first or down first? Well, it says it has to pass through this point right here. Pi over 4, 1. Pi over 4, I don't see a pi over 4. But 3 pi over 12, isn't that pi over 4? Yeah. So it has to pass through this point down here, which means then it would have to pass through this point up here. And if I graph that, this is my curve. That's not too bad. Yay, that's not too bad. Now that I've done that, and I think it said graph 2 cycles, I can't go any more that way. So what I'm going to do is I'm going to put these tick marks going this way. 1, 2, 3, 4. And I'm going to go back and do those same points. Start at 0, end at 0, 0 in the middle. But now I'm going to come down over here, because it's got to come down here. And then I'm going to go up here. Then get my thing, my pen, and that is the answer to that question. Let me try to zoom out a little bit, see it? There it is. That's the answer to that question. All right, let's do another one. Oh my gosh. So one portion of a roller coaster can be modeled by this curve, where t or h of t is represented roller coaster in hundreds of feet. Okay, hundreds of feet. That makes sense then. So here's the way I go about solving these. I didn't talk about why that's 4 points. The reason I use 4 is because I actually need 5. 1, 2, 3, 4, 5. Now 1 will always start at the origin, so I need 4 more new points. That's why I always take the period and divide by 4. So you'll see me do that again here. But we're going to go in order. A is my amplitude. That's equal to 5. I know it says -5. That's just direction. The negative is just direction. My b is the number in front of the variable. In this case, it's 3. At this point, I'm not gonna look at that equation anymore. I'm going to do period and scale. So my period is equal to 2 pi over b, which is 2 pi over 3. So I should be able to graph this thing in one full curve in 2 pi over 3. Now I'm going to do x scale. X scale is always going to be my period divided by 4. So in this case, it's 2 pi over 3 divided by 4. Well, if I divide by a number, I'm really going to multiply by the reciprocal, 1 over 4. So I get 2 pi over 12, which reduces to pi over 6. So I'm going to count by pi over 6's on the x-axis. And then my midline is y equals 2. Now, I want to graph 4 cycles of this curve. I'm going to graph 4 cycles of this curve. I'm going to put my x-axis here, my y-axis here. It's really hard. Make sure you please draw neat. The girls are so neat with their drawing. They're so meticulous and neat. And then I get some of the boys. And it's just, what is this? So, you know, if you want to know what your paper should look like, look at the girl next to you. For 99% of them are just writing so beautifully and meticulous. And the guys, you know, you guys need to work on your penmanship a little bit. But that's okay. Let's draw this in. My midline is 2, so I'm going to go up 2. So I might move that down just a little bit. Gosh, that's terrible. I'm going to draw with a smaller one on this anyway. All right, again, use a straight edge on the day of the test so your graph doesn't look like mine. All right, so Y scale. Get a Y scale on there. 2, -2. That's enough. That's all I need. I don't need any more than that. And then I'm going to put my X scale in, and I'm going to count by pi over 6s. And I'm only going for 4 of them, and I'll tell you why in another second. 1, 2, 3, 4. That's all I need to do in order to graph this curve for one cycle. So pi over 6, let me blow this up. Guess that's it. Pi over 6. 2 pi over 6, which is really pi over 3. 2 pi over 6. 3 pi over 6, which is really pi halves. And 4 pi over 6 would be the next one. 4 pi over 6 would be the next one. But isn't that just 2 pi over 3? Now, the reason I reduced this one and not the others is because isn't my period 2 pi over 3? So I should finish one full sine curve. Wait, sine or cosine? One full sine curve in 2 pi over 3. All right, so the first thing I got to do is draw my midline in. So let me zoom out a little bit, do my midline. Oh, why did I pick 2 again? That's weird. I'm going to go all the way down. Probably not going to finish graphing this one. All right, so my sine curve will always start at a 0, end at a 0, and 0 in the middle. Now, because this had a -5, because of this -5 right here, I know that I have to go down first. So in between these, I'm going to go down 5. 1, 2, 3, 4, 5. In between these two, I'm going to go up 5. 1, 2, 3, 4, 5. And then there is my first sine curve. Now, I'm going to kind of blow out, and I'm going to do this 1, 2, 3, 4. Here goes my next one. Goes down here. Boom, boom. Remember, start at 0, in the middle 0, end at 0, and in between these two is a max. And then do it again. 1, 2, 3, 4. Start at 0, end at 0, in the middle is 0, and down here is a min, and down here, up here is a max. So if I could just keep going, roller coaster fun, do it one more time, and you got 4. All right, moving on. Oh, you poor people on Lake Ontario, I feel so, I'm not kidding, this is crazy. Crazy what you guys are dealing with. Anyway, the water level is just raising like crazy right now. I apologize. I hope you guys are doing okay. All right, so my A value is -3. My B value is, now this case it's weird. It's hard to see actually. There it is. Oh my gosh, what am I doing? All right, my B value is pi over 4. Okay, stop there. Let's talk about period. Period is defined as 2 pi over B. Well, this is B, so this is going to get a little weird. It's going to be 2 pi over 4. Now, how do I get rid of that pi over 4? I multiply by the reciprocal. So I'm going to multiply by 4 over pi. Now, when I do that, I get 8 pi over pi. I'm sorry, my brain cramp right there. So the pi's cancel, so my period is 8. Huh? it's going to finish a full sine curve in 8. All right. So now I go to x scale. My x scale is equal to period divided by 4, which is just 2. Okay. And my midline is y equals 6. All right. So let's graph this thing. And there she goes. All right, so what do we got? Oh, let's put our scale on. 2, -2. All righty. And we got to put our y scale on. Now we're going to, now this is easy. This is nice. I'm going to count by 2s. 2, 4, 6, 8. I should finish a full cosine curve in 8. Full cosine curve in 8. All right. But I need my midline first, so let's get that midline in there. 2, 4, 6. There's my midline at 6. Ding, 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 ding. That's why I put the x-axis down a little bit further. Ba-chung. All right. So let's talk about this. It's a cosine curve. A cosine curve starts at a max and ends at a max. Or it starts at a min and ends at a min. Because this is negative, we're going to start at minimum. So instead of starting here, where normally I would start for a sine, I have to start at a minimum, down 3. 1, 2, 3. I'm going to start here. So I'm going to start at a min. I'm going to end at a min. And in between these two is not another min, it's a max. 1, 2, 3. And in between the max and the mins are zeros. So notice, once again, I get 4 points. And here's my curve. There it is. Now, that looks terrible. But it's going to start at a min. 1, 2, 3, 4. Start at a min, end at a min, max in the middle, zeros in between those. How many do you want me to do? I want to do 24 hours. So this was 10, 12, 14. This is 16. I got to do one more. 18, 20, 22, 24. Said for a full day. So start at a min, end at a min. In the middle is a max. In between those are zeros. Oh, there we go. Moving on. All right, guys, girls, try these on your own. Stop watching. Stop watching. Let's work on your own. Oh, you're back. Oh, my God. Good to have you back. All right, let's get going. A is, we're going to do another cosine curve. A is 4. B is 2. So now we go right into period. So period is equal to 2 pi over 2, which is just equal to pi. Okay, so I'm going to finish a full curve in pi. Okay, now let's do x scale. X scale is equal to pi, period, divided by 4. Okay, that's it. And my midline is y equals 2. All right, now in this case, I have to put my x-axis in the middle because it wants us to graph from negative pi to positive pi. So I'll pick someplace about in the middle. Hopefully that's close. And try not to be too bad there. Okay, that's pretty good. All right, whew, there we go. All right. So I want to go from negative pi to pi, but, all right, let me get my scale on there first. 2 and -2. I might grab my midline right now, just for fun. Oh my gosh, I picked 2 again? Why do I keep picking 2? That's so boring. You know, if the next one's 2, I'm going to think I got an issue. I got lots of issues, trust me. I got lots of issues. Major issues. I guess a midline can't be 2 one of them. Let's see if the next one's 2. Now, oh, that one's -1. Oh my God, I switched it up like crazy. So let me zoom in And let's talk about our scale on the x-axis. Again, we're just going to go out 4. We're going to go out 4 tick marks. 1, 2, 3, 4. That should be enough to graph a curve. And we're going to count by pi over 4s. 1 pi over 4, 2 pi over 4 is really just pi over 2, 3 pi over 4, and pi. I have to stop at pi because the direction said from negative pi to pi. So I also can go in this direction if I want to. I don't actually have to put these numbers over here, but I could. This is negative pi. I'll just start with that. It's less clutter if I do that. All right, so I got the midline drawn in. Because this is a cosine curve, it's going to start at a max or end at a max or a min. In this case, because it's negative 4, we're going to start at a min. I did another min too, really. I start at a min, end at a min. So we're going to go down 4. We're going to start at a min. We're going to end at a min. In between those two is a max. Now, why did I go down 4? I went down 4 because it says to go down 4. That's my amplitude. In between, I'm going to go up 4. 2, 3, 4. I'm going to go up 4. And in between those, I'm going to put zeros. So it looks like this. All right. Now, let's finish in the other direction. Start at a min, end at a min, in between, max. In between those, zeros. There we go. There's my curve. All right, one more to go. This is another sine curve. All right, this one's going to be a little crazier too. You should pause it, try it on your own, then come back and hang out with me. Oh, thanks for coming back. Now, this is a really weird one. They want me to graph from 0 to 12 pi. So A is equal to 1/2. B is equal to 1/3. Period is equal to 2 pi over, well, 2 pi over 1/3. That's weird. So I multiply by the reciprocal, which is 3 over 1, and I get a period of 6 pi. That means it's going to take 6 pi to finish one full sine curve. So this is 6 pi. I just didn't want to draw on there. And my x scale, this is going to be a little funky. My x scale is 6 pi over 4. Let's reduce that to 3 pi over 2. That's weird. And my midline is y equals -1. So they want us to graph from 0 to 12. So I'm going to put my y-axis over here. And I'll put my x-axis right down the middle. It's like I start out good and then end like crapola. And I'm going to go, this doesn't have to be very tall. I'm going to say this is 1. 1, 2, 3, 4. This is 2. -1. 1, 2, 3, 4. -2. You'll see why I did this in a minute. I don't have to do it this way, but I choose to do it this way. My midline is y equals -1. Let me draw that in. Dotted line. It has to be a dotted line because it's not part of the graph. There it is. All right. Let's get rocking and rolling and rocking. So, this is a sine. Oh wait, I haven't done my y-axis. So, let's do this. 3 pi over 2. Add 3 pi over 2 and 3 pi over 2. I get 6 pi over 2. 6 pi over 2 is 3 pi. 3 pi over 2 and 3 pi over 2 and 3 pi over 2 is 9 pi over 2. And 3 pi and 3 pi and 3 pi and 3 pi is 12 pi over 2, which is 6 pi. Now, didn't we say it was going to finish one full curve in 6 pi? So, here we go. Now, because this is a sine curve, right? This is a sine curve. It's going to start at a 0. It's going to end at a 0. And it's going to have 0 in between. That's not in between. This one's in between. So, now in between those, we're going to go max or min. Now we're going to go up. Oh, we're only going up a half. Now you know why I graphed it this way. We're going to go up a half. There it is. Up a half, and down a half. And I'll graph it. That's graphing it for 6 pi. 2, 2, 3, 4. 1, 2, 3, 4. So we're going to start at a 0, end at a 0, 0 in the middle, and then just keep the pattern going. There it is. That's it, kids. That's all she wrote for trig. I hope you guys enjoyed it. Sorry about my bad humor earlier. Hope I didn't offend anyone. Hope you can forgive me for my craziness. Catch y'all on the flip side. Goodbye. Hit that subscribe button. Hit the like button. See you all on the next one. The next one is exponential growth and decay. Goodbye, kids.